Hello, it is Friday, March 27th, and what are we doing today? I can design controlled experiments by randomly selecting and randomly assigning. So, you talked about the three different types of statistical studies. We talked about surveys, observational studies, and controlled experiments. We talked about the difference between them. The only way to get a causal relationship is through a controlled experiment. The main difference between a controlled experiment and the other two is that in a controlled experiment, there needs to be a treatment applied. So basically, here are the notes for this lesson. To design a controlled experiment, my first step is to randomly select a sample from the population, randomly assign half to a treatment group and half to a control group, administer the treatment to the treatment group, administer a placebo if possible to the control group, and then we're going to analyze the data to determine if there is a significant difference. And this step 4, we're not going to really do too much with that today. In the next lesson, we're going to talk about how to mathematically analyze the data to determine if there is a significant difference. So let's bring me up so I can kind of explain all this to you. And then we'll take a look and we'll do some examples. So basically, if I want to know if a drug is effective, let's say I'm a pharmaceutical company and I want to come up with a drug to combat coronavirus. Perfect timing for something like this. So to determine if it's effective, I need to do a controlled experiment. So my first step is going to be to randomly select a sample of the population. Now, the reason I say randomly select, I can't just pick the old people who are, unfortunately at great risk, because if I just pick the old people, they're probably not going to do as well because they're higher at risk for, issues from coronavirus. Also, if I pick a younger group of people, that's not going to represent the entire population, because in general, younger people are more resistant to it. So I need to randomly select a sample from the entire population. So maybe every fifth household in the country, every person whose last name ends in a vowel, I need to randomly select these people. Once I randomly select the sample, now I have, so think of it this way, I picked every fifth person in town and I brought them into the high school gym. So now I got a group of people in the high school gym. Now I need to randomly assign half of them to a control group and half of them to a treatment group. Again, I can't just say, okay, well, the people who look sickest, I'm going to give them the drug, and the people who look fine, I'm not. That's bias. I need to randomly. So now I'm going to maybe go, I'm going to go every other person. I'm going to go you here, you there, you here, you there, you here, you there, randomly. So half of them are on one side, the treatment group, half of them are on the other side, the control group. So now think about this gym. You have half of people on one side, half of people on the other side. I'm going to now administer my treatment to the treatment group. So the group that's receiving the treatment, I'm going to give them the treatment. Maybe it's a pill. I'm giving them the pill. Here you go. Take this. Take it, every 5 hours. Goodbye. Go home. I'm going to go to the control group and I'm going to give them a placebo. So here's what a placebo is in case you don't know what a placebo is. It's like a sugar pill. So I'm giving them the pill. It might look exactly like what I gave the other group, but it has no drug in it. It's just nothing. However, each group, they don't know if they're getting the drug or if they're getting the placebo. That's the whole point. They don't know. There's something called the placebo effect, where if you're getting a pill and you think it's going to do something, that your mind is going to believe that it's doing it. So this kind of counteracts the placebo effect. So they're getting a placebo, they're getting a sugar pill, they're being told the same instructions as the other group, they're being sent home. In a month from now, I'm going to reach out to the treatment group, I'm going to reach out to the control group, I'm going to see who got sick, I'm going to see who didn't get sick, and I'm going to compare the results to see if there's a significant difference. And again, the mathematical procedure for that, we're going to do that in the next lesson. So again, what did I do? I randomly selected a sample of people to participate in my study from the population. Maybe every fifth household I went and I picked everybody from that house. I I brought them all to high school, brought them all to the gym. Now I randomly assigned half of them to the treatment group, half of them to the control group. How did I do that? Every other person. You go here, you go there, you go here, you go there. Maybe I assigned everybody a number and I use a random number generator in order to decide who goes to this side, who goes to that side. The people who are randomly assigned to the treatment group, they're getting the treatment, they're getting the drug that I'm testing out to see if it works against coronavirus. The other group, the control group, is getting a placebo. They're getting a sugar pill. They don't know that it's a sugar pill, but it doesn't have any ingredients in it, doesn't have any drug in it. They're just getting this pill and they're being asked to take it. They're being sent home. And then in a month from now, I'm going to analyze the results to see if the people who got the drug did any better than the people who didn't get the drug. That's how we design a controlled experiment. This might sound familiar to you. You did this in living environment. You literally did this same exact procedure in living environment. So this shouldn't be completely new to you. It's really the same thing. The next lesson, like I said, we're going to do is going to kind of be something more than what you did in living environment. So we're going to take a look at some examples together, and that's it. It's a relatively simple lesson. Again, the main thing to know about designing a controlled experiment: randomly select a sample, randomly assign. As you see when we go through the examples, if you don't write randomly, you're not getting credit. It needs to be randomly select and randomly assign, because as we learned in the survey lesson, for a good sample, it must be random, not biased. So let's pull up the worksheet. So this is in your statistics packet, which you should all have. It's also on Schlansky.com, and the key is on Schlansky.com. At this point, I have no issues with you guys using the keys to help you. My main goal is for you guys to understand everything. A high school wants to determine if taking a Regents Review course causes students to score higher on the Common Core Geometry Regents exam. Describe a controlled experiment that can be created to test this hypothesis. So my first two words should always be the same. Randomly select a sample of students. Now be a little specific. My sample, my population is students in Common Core Geometry. I'm not going to pick students that are in algebra because I want to know if the Regents Review course is helpful for Common Core Geometry. So randomly select a sample of students in Common Core Geometry. Randomly assign half of them to a control. Let's make this bigger. To a control group and half to a treatment group. We are going to give the treatment group the review class. Now, in this case, there's really no placebo to give the control group. We can't trick them into thinking they're in a review class. So we're giving the treatment to the review class. We're giving the treatment group the review class, and the control group will practice on their own. And then we're going to analyze the data to determine if there is a significant difference. And for now, we're just saying that we're, analyzing the data. Again, in the next lesson, we're going to learn how to actually do that. It would be nice if I can make this text a little bit smaller so we could actually see it. Let's see if I can figure out how to do that. Nope, can't figure out how to do that. So that's fine. Okay. Let's take a look at the next example. A company created a pill that is supposed to reduce the length of the common cold. Describe a controlled experiment to test this hypothesis. All right. Let's see if I can make this smaller off the bat. I don't like this. do not like this. Okay. What are my first two words? Always. Randomly select a sample of people who have a common cold. If this is supposed to be tested on to see if it can reduce the length of people of, let me say that again. If this is supposed to be to test to see if it reduces the length of a common cold, your sample, your population is people who have a common cold. It wouldn't make sense to give someone who doesn't have a cold a pill to help them with their cold. Now that I have my sample, I'm going to randomly assign half to a treatment group and half to a control group. So now I have half of them on one side, half of them on the other side. I'm going to administer the treatment to the treatment group and give a placebo to the control group. This is an example where I could definitely give a placebo. Again, I don't even know. If I'm a participant in this study, I don't know which group I'm in. I was just told to stand over there. They gave me a pill and I took it. I don't know if it's the drug. I don't know if it's the placebo. That's the whole point. After that, we're going to wait some time. We're going to analyze the data to determine if there is a significant difference between the two groups. That's it. Why don't you take a look at number 3 on your own? Again, you don't have to have it word for word exactly the same as mine, but I'll kind of leave this up here for a moment and let you look at it. I know it's kind of hard to see with this thing. Then I'll do number 3, and then we'll go from there. So right now, just take a moment, try it on your own. Number 3. Some of you are saying, whatever, Schlansky, I'm not going to do it. Just I'm waiting for you like I do in class. That would be a poor choice. All right. Get me out of here. Oh. A farm is experimenting with a drug to increase the size of its chickens. Oh, that'll make them a lot of money. Describe a controlled experiment that can be performed to see if this drug is effective. So, again, first 2 words. Randomly select a sample. Now, a sample of what? I want to see if this drug is going to work on chickens. So am I going to choose students in Westbury High School? No, I'm going to randomly select a sample of chickens. Once I have the chickens that I selected, I'm going to randomly assign half of them to a treatment group and half to a control group. Again, I'm randomly assigning them. I'm not saying, okay, all the big chickens, I'm going to put them in the treatment group, and all the small chickens, I'm going to put them in the control group. That's biased. That's not going to show me if the treatment did anything. I need to randomly assign them. Chicken 1, chicken 2, chicken 3, chicken 4. All the even chickens go here, all the odd chickens go there. It needs to be random. All right, so now I got a bunch of chickens over here. I got a bunch of chickens over there. I'm going to administer the drug to the treatment group, and I will administer a placebo to the control group. There's no placebo effect in chickens. It's not like the chickens on one side are looking at the other chickens and be like, oh, you know, I wanted that drug, and I think that I'm not going to, you know, that's not going to happen. There's no placebo effect, but don't give them a placebo. No good. Don't give them a placebo. It probably won't really matter in that circumstance. Give them regular food. It's fine if the drug is in their food. Now I'm going to, I keep misspelling administer. It's bothering me. Now I'm going to analyze the data to determine if there is a significant. And listen, you might look at this. This might not be word for word exactly how I have it on my answer key. It doesn't have to be word for word anything. The only thing that it has to be word for word is randomly select, randomly assign. I need to see those phrases. At this point, your classwork / homework is going to be to finish this worksheet 4, 5, 6, 7, 8. Again, this is in your statistics packet. I'm going to give you a quiz, which will be due on Sunday night. It'll be a 1-question quiz. This one won't be multiple choice. You'll have to kind of type in your answer because this wouldn't really make sense as a multiple choice question. And that's it. If you have any questions, reach out to me on Remind, reach out to me through email. I'm here for you, whatever we got to do. Let me get out of here. See ya.